back later. Okay, I have problems in Microsoft Office. Okay, so the file wasn't opening in Microsoft Office. Okay, I don't know why, but I use another laptop and I solve the problem. Okay, by the way, we can say that Microsoft tools or Microsoft software or Microsoft Office is not good. Okay, I'm looking for another software that I can use and to work. Okay, so we told that today, learners, we will exactly find the exact roots of n degree polynomial equation. Okay, here we have, let's say, 11 degree polynomial equation. I'm going to solve it now in front of you using Ezouidi theorem. Okay, so we will train yourself, professors and teachers and colleagues, okay, and pioneers in methods to apply this theorem and to get rid of the usual methods like Isaac Newton or other approximation method that will deal that will give you exact roots with error estimation. But here in this example, we will never use a classical method. We will use my ways, okay, my special theorem, okay, of mine that had been discovered more than 13 years of work, okay, and now we can, let's say, work together and find the roots of, let's say, 11 degree polynomial equation. Okay, so we start, my kids. Here we have, let's say, our example. I'm going to share first of all, let's say, the screen with you, professors and teachers and colleagues and learners, to start work with Mourad Sultan Ezouidi, okay, solving 11th degree polynomial equation. 11th degree polynomial equation when the last term is imaginary. I'm going to go back maybe to imaginary. Okay, just a moment. I'm waiting for Microsoft. Okay, so we, let's say, give you an example where the last coefficient is imaginary or complex number. Imaginary number. Okay, so let's go step by step. So you will apply Ezouidi theorem today, and you will see that something really abnormal. Okay, okay, it comes here. Okay, let's do this example. Okay, stop here. So here, my kids, this is our 11 degree polynomial equation that to solve it now in front of you using Ezouidi theorem. Okay, let's start. So our polynomial of degree n, which is equal to 11, means x is 11 minus 33, x is to the power 10 plus 495, x is to the power 9, minus 4,455, x raised to the power 8 plus 26,730, x raised to the power 7 minus 112,266, x raised to the power 6 plus 336,798, x raised to the power 5 minus 721,710, x raised to the power 4 plus 1,082,565 x cubed minus 1,082,565 the square of x plus 649 and 539x minus 49 root of 5 times I. Okay, times I will change this one by times I. Okay, okay, make it out if it is better. Okay, this is I. Okay, so the last term is imaginary, is a complex number. Okay, so my kids, this 11 degree problem equation, it's called the original 11 degree problem equation because you should find the new 11 degree problem equation that corresponds to the original 11 degree problem equation. Okay, now after equating the original 11-degree problem equation by the standard form of this 11-degree problem equation, we should tell that L0 for equal to 33, L1 equal 495, L2 equal 4,455, and L3 equal 26,730, and up to L10, which is equal to 49 root of 5 multiplied by R. Okay, so you will use the coefficient, my kids. This coefficient has to be used in Ezouidi theorem to find out the, let's say, the x roots, okay, of this new 11-degree polynomial equation. Okay, let's start. Okay, so this is, my kids, the new theorem of Mourad Sultan Ezouidi. This one, S subscript k minus 1 for the R equal the sum from 0 to k, combination n minus r choose k minus r, and raised to the power r between parentheses negative 0 for the q, raised to the power k minus r times lr minus 1 for the q. Okay, you will set k equal 0, then equal 1, then 2, then k equal 3, then k equal 4, then k equal 5, then k equal 6, then k equal 7, then k equal 8, then k equal 9, up to 10, to find all s subscript k minus 1 for the q. Okay, this s subscript k minus 1 for the q, in fact, is the coefficient of your new 11-degree problem equation that corresponds to the original 11-degree problem equation. Let's start, my kids. So I'm going now to find s minus 1 by convention. S minus 1, my kids, we told is equal to 1. Okay, is equal to 1. S minus 1 is equal to 1. Simply set k equal 0, and you will see that s minus 1 equal to 1. Okay, now I'm going to put k equal 1 in the Ezouidi theorem. Okay, and you will see that in fact is equal to, this is, we call it's I. Okay, we told that in fact is equal to 0 because as 0 is the sum of the x roots, which is equal to 0. By convention, by substitution, the value, let's say L0 with 33 and with 11, I will obtain that as 0 in fact is equal to 0. Okay, now I'm going to find the S1. To find the S1, my kids, is very easy. Just do the theorem and set k equal 2. Okay, to put k equal 2, you will obtain S1 for the q is equal to minus combination 1 choose 1 times combination n choose 2 times the square of 0 for the q plus n square times L1 for the q. Okay, so let's do it. Okay, and of course you can use a calculator. Okay, so we will see that this is, we call it I. Okay, I'll put it here. I. This is I, we call it. Okay, okay, outside the, okay, like that. Yes. Okay, so now I'm going to find S1. We call put K in the discriminant formula of Mourad Sultan Ezouidi, and you will obtain that this is S1. Just make substitution, and you will get S1. In fact, is equal to. And now you can use your calculator and do your best, professors. And then we continue. We continue, my kids. Okay, we continue. So now I'm going to find what? To find S2. Okay, to find S2, you should set k equal 3 in the Ezouidi theorem, and then use the last formula that has been generalized written in its lowest term. Okay, let's see this formula. S2 will give you the third coefficient of your new nth degree problem equation that corresponds to the original nth degree problem equation. Okay, so let's wait for a while time. Okay. Now, my kids, we told that, okay, as we told that this is, of course, is now, this is, we told is 49. The last coefficient is 4 times I. Okay. Means the last coefficient L10 is equal to 49 of 5I complex number. Okay. Okay. This is I. Okay. Okay. So this is okay. Is 49 root of 5. Now, my kids, I will apply this formula of 2. Then I'm going to substitute L0 with 33, L1 with 495, L2 with 4455, and yes, up to L2. So this one, my kids, is equal to a now. Okay, is equal to a now. Okay. Okay. So we told that S2, my kids, is going to be equal to 0. Now I'm going to find S3. To find S3, it's very easy. Just go and set A equal 4. Where exactly equal 4 in equal 4 in Ezouidi theorem or in the discrete formula. Okay. So you will use S4, S3, this formula. Okay. We'll use this formula. S3 equal negative combination features 1 times n combination n choose 4 times L0 of the q raised to the power 4 plus combination minus 2 choose 2 and squared L0 of the q squared times L1 minus combination n minus 3 choose 1 times L0 for the 2 times L2 plus the n raised to the power 4 times L3 for the q. You will just use this one, I mean, okay? You will find that the value of S3, my kids, is equal to NL, okay? Is equal to NL. Okay, of course, the last is 49 root 5i. Now I'm going to find S4. To find S4 is the same as you will set K equal 5, okay, in the discrete formula of Mourad Sultan Ezouidi, and you will focus on the last general the last formula that had been generalized and written in its in its lowest term. We call this the last coefficient here is root 49 root 5i. Okay, let's see. Now, if you calculate S4, S4 here will give you the fifth coefficient of your new 11th degree polynomial equation. So now we should continue. So this one S4 is going to be equal to 0. I should continue to find what? To find S5. To find S5, just my kids put k equals 6 as the decimal formula of me and make expansion, and you will write S5 in its lowest term like that. Now, just put L0 with 33, L1 with 495, up to L5, which is equal 336,798. Then you are going to use a calculator, and you will find that is going to be equal to NO. Okay? So means what to NO? Means that the value of means the value of S5 is equal to 0. Okay? So now I'm going to find S6. To find S6 is very easy. Go and put k equals 7. Okay, in the Ezouidi theorem, or apply Ezouidi theorem. Okay, sorry, let's see the name. Apply Ezouidi theorem and find, let's say, S6 means put k equals 7. I will see if I change this one. Yes, I change it. Now this one is gonna be equal to 49 root 5 times I. Okay. I don't know why Microsoft is too low. Okay. Okay. So we continue. Means that put k equals every decimal formula, and you should, let's say, make expansion or expand the sum and write it in its lowest term. You will find the formula that will give you the seventh coefficient of your on single I, not double I. Okay, of your, yes. Okay, we'll wait. Okay, now, sorry. Now, my kids, we told that make your own substitution. Make your own substitution. This is there. Enter. Make your own substitution. Main is put L0 with 33, L1 with 495 in this formula, and you'll get that the value of 6 is going to be equal to 0. Okay, yes. Now we continue, my kids. We continue. I want to find S7. To find S7, just go and use again, what? Use again Ezouidi theorem and put k equal 8 will obtain a 7. So a 7 here is written in its lowest term, the last one, you see this one. Now make substitution and you find that the value of S7 is going to be equal to 0. Kids, in fact, and my professors to find the value of S8 and S9 and S10. So only 3 steps are left. Then we are going to find the x roots of our new 11-degree Coulomb equation. Okay. Now put k equal 9 to obtain S8 and write S8 in the West like that after making the expansion of the sum. Okay, and then making substitution. After making substitution, my kids, you will see that the value of S8 in fact is going to be equal to 0. Okay, but I'm going to change this one by 49 I. Okay, 49 root of 5 I is out. Okay, like that. Okay. Now I need to find what to find. Okay, to find not this. To find S9. To find S9 microsers, just put k equal 10 in the discriminant formula of Mourad Sultan, and then make the extension of this sum and write, let's say, L0 for the q raised to the power 10 as a common factor. And after that, writing your formula S9 in its lowest term and make your own substitution using the coefficient of your original 11 degree from equation from L0 up to L9. Okay, so okay, make this equal. Okay, now I should find which is going to be equal to 0. Okay, 8 S8 is equal. Now I'll go back down. I want to find S9. With S9, you should put k equal in the Ezouidi theorem, in Mourad Sultan Ezouidi theorem. Okay, let's do it. This is the Ezouidi theorem, this one. Okay, the green one. Okay, I will put k equal 10 to obtain S9. 10 minus 1 is 9. Then make the expansion and write, let's say, after making L0 for the q raised to the power 10 to the power 10 and write it in its lowest term, you can make your own substitution and calculate. Okay, let's do it. Now comes here. Word not displayed. Okay, this is okay. You see, in fact, Microsoft Office is not a good software. Okay, it's a man with software. By the way, okay, we are here to solve this problem. Okay, so after Office, he can solve this kind of questions. I gave him so many questions. He told us we can do nothing for this kind. Okay, we'll wait. This is we told. Okay, this is 49 49 يعني 49i complex number. Okay, I'll make save. So this is according to Mourad Sultan Ezouidi theorem. You can solve this 11 degree from the equation. Okay, and going step by step to know how to apply it and to know the relationship. Okay. Now the last term now is and just put k equal 11 because 11 degree from equation. 11 minus 1 will give you the last coefficient of your new 11 degree from the equation, and then we'll make our conclusion and go back to find the roots of our original differential equation using Mourad Sultan Ezouidi theorem. Okay, now we put k equal. I will put k equal stop here. Okay, comes here. Okay, I. So now I told that putting k equal 11. Okay, to find S10. Okay, so this is 11, my kids. 11. Okay. Okay. Now just make substitution. Put k equal 11 and we will obtain S11 minus 1 will give you S10. That's why he certain S10. Okay, minus when R equals 0, that's why he N should be 11. The minus 1 to the power k is equal to 11. So minus 1 to the power 11 is negative number. We put it in front here. Then at 11, then continue the expansion. Okay, and we obtain the last formula as 10 equals that. This will give you the 11th coefficient and degree polynomial equation. Okay, so this one has to be equal to root of 5i. Okay, now my kids, I want what exactly? I want now to make our conclusion. Right. Now, okay, now we told, okay, the series is 10, okay. Now my kids, we told that S10 now after making the substitution, you will find that S10 is 11 to the power 11 between parentheses negative 3 raised to the power 11 plus 49 root 5 root of 5 times I. Root of 5, the root of 5 I. Okay, so this is the last coefficient of your new level equation equation. Okay, yes. Now, go down and make your conclusion. You will write your new 11 equation as that x raised to the power 11 minus s0 x raised to the power 10 plus s1 x raised to the power 9, yes, plus s2 minus s2 x raised to the power 7 and up to s10 equals 0. Okay, let's see this one. Okay. Or yes, like that. Okay, so this is my kids, we told that this is s all of the s0 s1 s2 s3 s4 s5 s6 equal 0 except s10 which is equal to you get 11 raised to the power 11 times negative 3 raised to the power 11 plus 49 root of 5 I root of 5 I like that. Okay. Okay, now we are going to solve this one. So this, the new 11 degree formula has to be written like that in terms of s subscript k minus 1. Now, all the s subscript k minus 1 are equal to 0 except the last one, okay, which is equal to 11 to the power 11 between parentheses, negative L0, of course. This is between parentheses, this one. Okay, we told what is it? This one, yes. Here, come here. We wait for while time. Okay, okay, okay. So this one we called is then we are to write, let's say, to write this as that. Okay, this is also is safe. Okay, we continue. It remains only two steps, then we finish the string the solution of this 11-degree problem equation. Complete, let's say, the uh, misfunction of Microsoft Office. Okay, okay. So I'm going to write here, let's say, we come here. Okay, no problem. I will see where exactly. Okay. I'll make this is 49. So 49. root of 5i. Just here, my kids, we will change this one with 49 root of 5i, and this one also 49 root of 5i, and this one also I. Okay, because the I don't know what happened to the Microsoft Office. It's yeah, foolish tools. Okay. Yes, I'm recording. Yes. You want something? Okay. So this one is 49 root of 5i raised to the power 1 over 11 exponential 2k plus 1 I pi over 11. Then the x roots has to be written as 11 3 raised to the power 11 minus 49 root of 5i. Okay, raised to the power 1 over 2k plus 1 I pi over 11. Therefore, you see Microsoft in fact is not good too. Okay, I hate this Microsoft tool. Okay, because it helps Said to kill Gaza killing. This is it too. So, by the way, okay, we hope that Gaza kids will be fine. Okay, so this is I. Okay, like that. So this is also is I. Okay, now it comes is I. Okay, this is I. Okay, this is I, my kids. This is I. Not go outside the roots, Mr. Moral. Okay, like that. Good man. This is called is coming here. Parentheses. Okay, like that. Because 11 raised to the power 11 times this and that. Okay. Okay, let's see. Also, this one makes is the parentheses. Okay. So we go back now. Everything is correct. So okay, this is correct. This is I, and this one is going to be I. So we finish the question. So now we solve it really this 11 degree problem, but I'll change the coefficient this one. Okay, I. Okay, you can see 33, 11 divided by 11 plus 33 minus 33 is 0. It remains only 11, 3 raised to the power 11 minus 49 root of 5i, all raised to the power 11, a to k plus 1 I pi over 11. The ykx roots of this new level differential equation. But this one, it's called what? It's called my kids, the roots. My original level differential equation, of course, from 0 to 10. To 10. Okay. So the C is 45, 4 to 5i. Okay. Helps. So this is my kids now. This one follows the x roots of my new 11 degree from the equation, and these are the exact roots of our polynomial. We'll simplify more. It will be 33 divided by 3 will give you 3. Let's do like that. I'll make copy if possible. Okay, I'll make that. I'll see if it works or not. Even cat doesn't work. Okay. So, by the way, this one is the roots. Okay, to divide 33 by 11 give you 3, and 11 by 11 give you this one. So these are the roots of my 11 degree equation. Thank you for listening. I will save this one. Okay, then I will. Okay. Okay, so thank you for listening. This is Mourad Sultan Ezouidi. We really solved 11th degree formula equation using Ezouidi theorem, the decimal formula of Mourad Sultan Ezouidi. We hope so that one day we can use other formula. That in fact, I have published many things. Okay, and the third theorem will deal with solving nth linear equation that has a relationship between nth degree formula equation. But we hope so that time will help me explain this. Okay, so this is Mr. Mourad Sultan Ezouidi. Okay, is here to let you know how to use the decimal formula and solve linear and solve nth degree formula equation using what? Using my theorem, and all the roots here are radical. Okay, so this one is like can tell you example for double theorem. Okay, and it's a good method also in like in Isaac Newton and other approximation method. Thank you and goodbye. See you next time. Goodbye. Thank you. Thank you. Thank you.